The next heading before us is non-homogeneous differential equations convertible to homogeneous form. This is the heading. Well, my dear friends, we have already covered two models. One model is variable separable and the second model is homogeneous differential equations. We are now looking at non-homogeneous differential equations. And if you go through the question papers of various years, a little importance will be given to this because the procedure is lengthier and there will be no shortcuts. There will be no shortcut at all to reduce the procedure. That is why even the examiners give very little preference to these equations. Even then, we must be knowing the procedure, whatever large it may be, whatever difficult it may be. We must be knowing it. For that purpose only, I just solved two or three problems for this, so that you can understand the method of solving it. Okay, first of all, let us understand the standard form of these equations, which look like homogeneous but not homogeneous. Of course, by simple techniques or simple adjustments, we can convert that into homogeneous form. Let us understand what is the standard shape. You please observe the equation. Dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. See, if c1 and c2 are not present there, then it becomes homogeneous. Simply because of the presence of c1 and c2, both numerator and denominator are not going to be told as homogeneous. Yes, if you omit c1, c2, or if you choose the origin suitably such that the constants might be eliminated, then it can be converted to homogeneous form. That is why even in the heading itself, we could have taken convertible to homogeneous form. Well, my dear, even in this form, there are two cases. That is, case 1, a1 by a2 is equal to b1 by b2, and case 2, a1 by a2 is not equal to b1 by b2. There are two different cases. Of course, out of these two cases, the first case is a very simple case, so that in that case, even though the equation is non-homogeneous, it can be transferred to variable separable form directly, so that it becomes very easy, of course, to solve it directly. Let us look at one such example for case 1, and then we shall shift our attention to focus on the second case or second model. Well, so we take interest to consider the non-homogeneous differential equation of case 1, that is a1 by a2 is equal to b1 by b2. What does it mean? Consider the equation dy by dx is equal to x plus 2y plus 1 by 2x plus 4y minus 1 minus 1. Observe it. a1 by a2, 1 by 2. b1 by b2, 1 by 2. You see, a1 by a2 is equal to b1 by b2. The equality is just nothing but you will be in a position to have a common factor in both numerator and denominator. That's all. You can have this as 2 into x plus 2y, isn't it? that makes stronger, of course, about the procedure. It can directly be converted into variable separable model. Let us observe that. Let x plus 2y is equal to t. X plus 2y is equal to t. Why should you take x plus 2y only as t? Because it occurs twice, here and here. Here t is available and here it is 2t is available. That is the loophole present in that model. Yes, of course. That is the thing which helps us a lot to get it converted into variables separable model. Okay. Come on. What is its derivative? 1. 2 dy by dx is equal to dt by dx. Okay, therefore 2 into dy by dx is equal to dt by dx minus 1. Well done. Multiply this with 2. What happens? Let me call this 1. 1 implies 2 dy by dx is equal to 2 into x plus 2y plus 1 by 2 into x plus 2y minus 1. But you see, 2 into dy by dx is nothing but dt by dx minus 1. dt by dx minus 1 is equal to 2 into, this is t plus 1 by, this is 2t minus 1. 2t minus 1. From which dt by dx is therefore equal to 2t plus 2 by 2t minus 1 plus 1. Plus 1. And take the LCM now. This is 2t minus 1, 2t plus 2 plus 2t minus 1. Okay, this is 4t plus 1 by 2t minus 1. By 2t minus 1. It is surely, directly, simply, evidently, clearly in the form variable separable model. You bring all those t's to this side and send dx the side, so that you may be having 2t minus 1 by 4t plus 1 dt is equal to dx. Is equal to dx. And you see, at this juncture, you may not have any simply adjustments or any other ideas. You can directly divide the numerator 2t minus 1 with the denominator. What happens? 4t plus 1, half. Half into 4t is 2t. Half into 1 is plus half. This is minus 1. You subtract, it is minus 3 by 2, isn't it? Therefore, this particular fraction can be taken as half minus 3 by 2 by 4t plus 1 dt is equal to dx. Is equal to dx. I think you are familiar with this division, which can be explained in our earlier classes like 8th class, 9th class, like that. You follow these steps. I'm now ready to remove these steps. So that is, while integrating, it is half into t minus 3 by 2 into log mod 4t plus 1 by 4 is equal to x plus c by 8. I like to have. Multiply throughout by 8. What do you have? 4t minus 3 log 4t plus 1 is equal to 8x plus c. And in the place of t, you replace, what is t? What quantity is supposed to be t? Some x plus 2y, isn't it? Okay, so 4 into x plus 2y minus 3 into log of 4 into x plus 2y plus 1 is equal to 8x plus c, and the simplification can be done according to the convenience, according to the options, according to the necessity. I like to stop here itself. We are just interested to know the style of solving it. That's all. I think you could have followed very easily. If at all there is any difficulty, of course it is not difficulty, you can estimate it. Half into 40 plus 1, you can have minus 3 by 2. It's very simple, of course, right? If you are doubtful about your ideas, then you directly have the division like that, so that this will be the answer. And to know this perfectly, let us make use of one more example which belongs to this case. Observe the problem. Dy by dx is equal to x plus y plus 1 by 2x plus 2y minus 3. X plus y plus 1 by 2x plus 2y minus 3. And in this problem also, it is very easy, of course, to notice that this belongs to case 1. Why? Because 1 by 2, 1 by 2. And x plus y can be formed as a common expression in both numerator and denominator. Well, what can be grasped out as a common expression in both numerator and denominator? It's nothing but x plus y. I think you please recollect the procedure which we could have used in the previous problem. We have supposed something as t. What is that something? That is that something which can be observed in both numerator and denominator as a common expression, isn't it? What is the so-called common expression here? X plus y. That's good. Put x plus y is equal to t. I think you could have followed my words previously. In the previous problem, we could have observed a particular expression which is common in both numerator and denominator. You please recollect, that was x plus 2y, isn't it? Just like that one, just like that problem, here in this problem, we have that particular expression as x plus y. It is available in the numerator and in the denominator also. Simply by that reason, I am supposing it to be some t. This implies for x it is 1 and for y it is dy by dx is equal to dt by dx. dt by dx. You believe that we have added 1 on both sides, or else there are simple steps. Okay, no problem. Dy by dx is therefore equal to dt by dx minus 1. Therefore 1 becomes dt by dx minus 1 is equal to t plus 1 by 2t minus 3. 2t minus 3. Therefore, dt by dx is therefore equal to t plus 1 by 2t minus 3 plus 1. Plus 1. The next step. Therefore, dt by dx is equal to t plus 1 plus 2t minus 3 by 2t minus 3. 2 plus 2t is 3t, 3t minus 2 by 2t minus 3. This is dt by dx. Therefore, 2t minus 3 by 3t minus 2 dt is equal to dx. 2t minus 3, 3t minus 2. Come on. 2 by 3 times. 2 by 3 into 3t is 2t. 2 by 3 into 2 is minus 4 by 3. Subtract them. What happens? 4 by 3 minus 3. 4 by 3 minus 3 is 4 minus 9 by 3. That is minus 5 by 3. Isn't it? Therefore, you can have this expression as 2 by 3 minus 5 by 3 by 2t minus 3 dt is equal to dx. Is equal to dx. So that is 2 by 3 into integral 1, 5 by 3 into integral 1 by 2t minus 3 dt integral dx is equal to integral dx. And you could have understood that we have already reached the position of climax to have the direct answer. We have it by following the last step. It is 2t by 3 minus 5 by 3 into log of 2t minus 3 by 2, don't forget it, is equal to x plus c by 6. I like to write because I'm going to have 6 as the LCM here. Okay, right, it is, let me multiply with 6, so that 4t minus 5 into log mod 2t minus 3 is equal to 6x plus c. Now you replace x plus y in the place of t, that is that expression which we have supposed t in the beginning itself. Okay, right, what is that? 4 into x plus y minus 5 into log of 2x plus 2y minus 3 is equal to 6x plus c. You can do still something. What is that something? 4y minus 2x minus 5 into log of 2x plus 2y minus 3 is equal to c. That's all. I've justly brought the 6x to this side. Already 4x is available. 4x minus 6x becomes minus 2x. So this is the solution. Like that, we can make an attack and approach on the first model of non-homogeneous differential equation. Well, it is now our time, the right time to look at, to concentrate on the second model, that is when a1 by a2 is not equal to b1 by b2. What is going to happen? You see, the first model is very simple, but the second model is somewhat large. That's all. A few steps will be increased. Just a few steps will be increased, no problem. Let us understand that style also. Let us now turn our head towards the second model in this heading, that is non-homogeneous differential equations which can be convertible to homogeneous form. You observe and this can be explained by means of an example only. Yes, look at this example. dy by dx is therefore equal to 3y minus 7x plus 7 by 3x minus 7 by minus 3. a1 by a2 minus 7 by 3, b1 by b2 minus 3 by 7, they are absolutely not equal. So the first method, the first model is not applicable here. Well, let us try to get it simplified. This is equal to minus 7x plus 3y plus 7 by 3x minus 7y minus 3. This is a dy by dx. Call this 1. In the beginning itself, while looking at the heading, we have told that this can be converted to homogeneous form. Okay, what is the main obstacle here for us to say that this is homogeneous? This 7 and this minus 3. They act as villains for us, which object us to say that it is homogeneous. We have to remove them. How can they be? Look here. Let x is equal to x plus h, y is equal to y plus k. If you put x plus h here, minus 7x minus 7h plus 3k plus 7 will be the constant which will be going to come. Such that, come on, minus 7h plus 3k plus 7 is equal to 0 and 3h minus 7k minus 3 is equal to 0. We are choosing small h and small k in such a way that these two happen. What is the benefit of getting like that? If you put x plus h and y plus k here, what will be the nature of this? Minus 7 capital X, 7h, 3 capital Y, 3k. Minus 7h plus 3k plus 7 is going to be made 0. That is the benefit you are going to have. In this situation, dx is equal to d capital X and dy is equal to d capital Y. Therefore 1 implies, come on, d capital Y by d capital X is equal to minus 7x plus 3y by 3x minus 7y. What about the constants? They have been annihilated. They have been reduced. They have been discarded, of course, with the help of this condition. And now, this is homogeneous. Surely this is homogeneous, isn't it? Okay. Call this 2. As usual, put y is equal to vx. Everything is a capital letter. Y is equal to vx. Then dy by dx is equal to v plus x dv by dx, isn't it? dv by dx. So 2 becomes dy by dx. In the place of dy by dx, we have to write v plus x dv by dx is equal to minus 7x plus 3vx by 3x minus 7vx. Of course, you divide both numerator and denominator with x, or you get x as a common factor in both numerator and denominator. They will automatically be cancelled. So that this is equal to minus 7 plus 3v by 3 minus 7v. This is all v plus x dv by dx is equal to. Well done. From this, x dv by dx is equal to, from this, the pattern of homogeneous equations, the style of homogeneous equations is entirely be repeated. And at last, you will be going to have the answer in terms of capital X and capital Y. And in the place of capital X, we have small x minus h. And in the place of capital Y, we have small y minus k. At that instant, we are supposed to substitute. Okay, let us proceed. X dv by dx is equal to minus 7 plus 3v by 3 minus 7v minus v is equal to minus 7 plus 3v minus 3v plus 7v square. 3v and 3v go away, leaving you 7 into v square minus 1 by 3 minus 7v. 3 minus 7v. This is x dv by dx is equal to. Okay. Therefore, 3 minus 7v by v square minus 1 dv is equal to 7 dx by x. Now, in order to integrate it, this may have to be split into 2 parts. What are they? 3 by v square minus 1 minus 7 by 2 into 2v by v square minus 1 dv is equal to 7 dx by x. Let us try to integrate it. 3 into 1 by v square minus 1. What is the integral? 1 by x square minus a square. Come on. What is the formula? 1 by 2a log mod x minus a by x plus a. According to that, it is 1 by 2a, means 1 by 2 into log mod v minus 1 by v plus 1 minus 7 by 2 into, come on, 2v by v square minus 1. What is that? F dash v by f of v. Derivative of v square minus 1 is nothing but 2, isn't it? So it is log mod v square minus 1 is equal to 7 log mod x. 7 log mod x. Logarithmic function, logarithmic function, logarithmic function. Everywhere you are having logarithmic function. And therefore, in the place of the constant also, we shall introduce it 1 by 2 log c. Let me write. Why should we have 1 by 2? Why? Because 2 is there. Now multiply this with 2. What happens? 3 into log mod v minus 1 by v plus 1 minus 7 into log mod v square minus 1 is equal to 14 log x plus log c. Or even in the place here itself you can have 7 by 2 also. 7 by 2 log c. If you can put, then 2 will be cancelled and let it be 1 itself. So log of v minus 1 by v plus 1 whole cube minus log of v square minus 1 whole to the power of 7 is equal to log of x power 14 into c. Now two types of transactions are still remained. What are they? Number one, in the place of v, you are supposed to have y by x, capital Y by capital X, so that it is log of, what is y by x minus 1 by y by x plus 1? Y minus x by y plus x whole cube minus, it is y square by x square minus 1. What does it mean? Log of y square minus x square by x square whole to the power of 7 is equal to log of x power 14 into c. Of course, in the last step, you are supposed to have capital X is equal to small x minus h, capital Y is equal to small y minus k. What are h and k? They are to be determined from where? From these two conditions. Come on, solve them. H by, from these two, is equal to minus k by, come on, minus k by 21 minus 21, 21 minus 21, 0, let it be. It is a ratio only, do not get confused. 1 by 49 minus 9, 40. Therefore, h is 1 and k is 0, isn't it? H is 1 and k is 0. H is 1 means in the case of capital X, we have x minus 1. In the place of capital Y, small y, because k is 0. That gives us the solution. This is the process to be obtained. Simply because of this reason, the examiners do not show much interest on this model. And we too do not solve and one more problem on this. Stop here itself. This is about homogeneous and non-homogeneous equations.